All right, welcome back. Today we're going to be talking about section 3.1. We're going to be talking about relationships and functions, or just a relation. So you understand what the word relation or relationship means, okay? Now we're going to refer them back to a mathematical term, which is a function, okay? So let's refer to a vending machine, okay? I want you to think about a vending machine. I'm going to try to make sense of this. So if you want a vending machine, let's say you want a Pepsi. So if you want that Pepsi, how are you going to get that Pepsi out of the vending machine? Well, obviously you're going to put in that $1.50 or however the amount is. But how are you going to get that Pepsi out of the machine? You're going to hit a button, right? And let's say that button is A4. Okay. Now that A4 is going to pop out a Pepsi, right? Good. Now, that A4 that you pressed, the A4 that you pressed, let me get a highlighter, is going to be referred to as the input. That's what you inputted to receive what you wanted, and what you received is your output. Okay? And this is a relationship. Okay? The A4 is connected only to a Pepsi. The A4 is not connected to a Coke or a Mountain Dew or a Sprite. It's just connected to a Pepsi. So every time you're going to hit A4, it's going to output a Pepsi. All right? I'm going to refer back to that example. Now, let's go through some terminology to kind of make sense of all this. So if I talk about a relationship, okay, it also could be represented by a set of order pairs called a coordinate. Coordinate pair or point. Okay, so that's just saying I have an x and I have a y. Okay, in this case, what's my x? Okay, my x is what you're inputting. So my x is A4. Okay, my output, okay, or my y is going to be my Pepsi. Okay, cool. Now, I'm going to break down the A4 and the Pepsi as my input and output. Okay, the input, okay, the input of a relation or relations is the set of the first coordinate, x value, of the ordered pairs. So in this case, it's just the A4. Okay, so my A4 is what my input is. Okay, good. Now, if I talk about the opposite, okay, I'm talking about my output. Okay, the output of the relation is the set of second order pairs, or the second coordinate, the y values of the ordered pair. So if I'm talking about A4 comma Pepsi, I'm saying when I plug in A4, okay, I'm outputting the Pepsi, and that's what my output is. So let me get a highlighter. Let's go with green, and that's my output. Okay, cool. Now, when I put this all together, okay, a function is a special type of relation or relations that pairs each domain value with exactly one range value. Now, excuse me. Now, these are new words that I'm going to tie into words that I just wrote. So I can use input, okay, or I could use domain. Okay, so domain is your input or your x values. Okay, good. Or you could say my range. Okay, for my output values or your y values. Okay, so throughout this presentation, I'll use input, I'll use domain. They both mean the same thing, or x values. I'll use output, I'll use range, or I'll use y values. They all mean the same thing. All right, we cool? So now, if something isn't a function, okay, if something isn't a function, say I went and I plugged in A4 and a Pepsi popped out. Okay, good. And then my buddy Ryan came behind me. He was like, "Oh, I want a Pepsi too," and he put in money, and he hit a 4, and it popped out a Coke. Okay, so I plugged in the same input and an output of Pepsi the first time. I inputted the same input value and it output a Coke the next time. So it outputted two different things. That would not be a function. I'm going to get into that in a little while. Okay? So a function is if I hit A4 and every time it pops out a Pepsi. Something that's not a function is if one time I hit A4 and it pops out a Pepsi, and next time I hit A4 it pops out a Coke. Okay, so now kind of let's represent this information, okay, or data in 3 different ways. So I don't know what this information is, but I know that I have data values like such. I have 2, 3, 4, 7, 6, 1. Now I'm going to say that I want to represent this information. I'm going to tell whether this data represents a function or not, just like my vending machine example. So if I talk about this data, I'm saying, okay, one way I can represent this data is on a graph, and simply all I'm going to do is graph those points. So 2, 3 is right there. 4, 7 is off the graph somewhere up there. 6, 1 is somewhere right there. Okay? So I just graph those points. So that's how I represent that information on a graph. Now, if I was going to represent this information using a mapping diagram. Okay, a mapping diagram is something that you might not have seen before, but it's another way to represent data and to determine whether it's a function or not. So if I want to represent a mapping diagram, if you just want to pause the video to draw these columns, okay, so you could organize. Now, when I go ahead and draw my mapping diagram, I want to take all of my input values, and my input values are all of the first values. So I have a 2, I have a 4, and I have a 6. Now what I want to do with those values is I want to list them from least to greatest without repeating in my input. So least to greatest without repeating. So the order is going to be 2, 4, 6, right? 2, 4, 6. Least to greatest without repeating. Good. Now I'm going to do the same thing with my output values, which is the second point of my ordered pair. Okay, so I have 3, 7, 1. Now, least to greatest without repeating. Least to greatest. Let me write that down. Least to greatest without repeating. Okay? So now, when I go ahead and write that, I'm going to write 1, 3, 7. Now, what I'm going to do is I'm going to take an arrow and I'm going to draw an input value to its matching output value. So I'm going to look at 2. When I inputted 2, it outputs a 3. So all I'm going to do is take my 2 and draw a line to a 3. Same thing. When I input a 4, I output a 7. Input a 4, I output a 7. Good. Last one I'm going to do is I have a 6. Okay? And it outputs a 1. 6 outputs a 1. And I represented my data in that fashion. Awesome. Okay? Good. Now I represented all of this data. Okay? I have one more type of data that I'm going to show you, which you already know. Then I'm going to go through and determine whether it's a function through all 3 methods. Good. Now I'm going to have a table. Something that you know, the first one's going to be your x, your next one's going to be y, and these ones you could just simply write as listed. Okay, so it's going to be 2, 3, 4, that's not a 4, 3, 4, 7, 6, 1. Okay, good. Now, I'm going to refer back to my domain and range, and then I'm going to answer the question whether it's a function or not. So now, my domain is just all of my x values. So the easy one to probably do is the mapping diagram, because your domain is the same thing as saying input values. These are already in least to greatest order without repeating, and that's how I want your domain to be. So just remember your domain is like your x. So what are your x's? In this case, it's 2, 4, 6. Awesome. Your range are your y values. So here my y values from least to greatest. Without repeating, it's going to be 1, 3, 7, 1, 3, 7. So I just represented this data. Okay, I represented this data in that fashion. Okay, good. Now, the last question is important. The last question is whether this represents a function or not a function. So in this case, I'm going to look at my graph first. Simply, okay, are there 2 points that lie on top of each other? And I'm going to explain why in a second. So I have a point here. Is there any other point that lies on top of that? No. Another point here, does it lie on top? No. So another point here, does it lie on top? No. Okay? So remember back to the vending machine. So my input only has one output. So this down here, all of my x values are my inputs. So if I inputted 2, I only outputted 3. That makes sense. If I input a 4, I only output a 7. If I input a 6, I only output a 1. So if none of these points are on top of each other and have the same x value, then yes, it is a function. Okay, now let's do that same, let's go through that same process, but now let's use a mapping diagram. Now using a mapping diagram, simply, all you're going to look is to see if your input doubles up with arrows, because remember, if I input a 2, it only is going to output a 3. It's not going to output a 1 as well. If I input a 4, it's only going to output a 7. That's not going to output another number. So I have 1 arrow there, 1 arrow there, 1 arrow there. Yes, it is a function. Okay? That's the second way. Now simply, when I use a table, just look at your x values. Do any of your x values double up? No? In that case, it would be a function. Now, let's say I had another value of 2, 3. Well, if I input a 2, I output a 3. Same thing as saying input a 2, I output a 3. It doesn't have a different output. So that's the same thing. So it wouldn't matter if there was an extra value of 2, 3. Okay? So yes, it is a function. Okay, so now I want you to try this problem on your own. Okay, it's going to be a money problem. Pause the video, refer back to my examples, my prior examples, and good luck. All right, now the last type of function I'm going to look at is when I'm given a graph, okay, a shape or some sort of illustration on a graph, and I'm going to determine whether it's a function or not. And to list out all of these points that are on this line is virtually impossible. It is impossible, okay, because there's an infinite amount of numbers on that. In this case, it's a triangle, right? Okay, so I'm going to use something called the vertical line test. Okay, the vertical line test. Now remember what a function is. So let's go back to our notes. So a function is a special type of relation that pairs each domain value with exactly one range value. Okay, so each domain value with exactly one range value. So meaning I could only have one input, okay, only having one output. Okay, I'm going to use this using a vertical line. So if you just want to draw a line from up to down, like such, and I'm going to make it a different color. Let's make it, I don't know, blue. Okay, and I'm going to take this line. I'm going to drag it from left to right. Now, at that point, just stop. Now, how many points does that blue line, let me go up. How many points does that blue line touch your illustration? So in that case, I'm going to say touches once there and once there. Do you agree? Good. Let's move it again. Say, stop it right there. It touches once there and once there. Good. So now, it is not a function, okay, if it touches more than once, right? Because x value only has one output value. If I input a 2, it can't output, in this case it looks like a 1 and a -2, right? So this would be not a function. Okay? Not a function. Awesome. Now, in that case, I'm going to go ahead and test my second graph. Okay? So this is really all I'm asking. Is it a function or is it not a function? Okay, so I'm going to drag this from left to right, and I'm going to say, okay, I'm going to stop right there. How many times does that touch your graph? And it only touches right there. Okay, let's try this again. Let's move it right there. It only touches right there. Alright, let's try one more time. Let's go back here and stop. It only touches right there. Okay, so as I went through, at one point it only touched once. So if it only touches once, okay, then it is a function. Okay, it is a function. Okay, it is a function. Awesome. Okay, so this is called the vertical line test. Now you could always do this with a graph or even with points, right? So if you went back and wanted to use this graph, right? Okay, if I use this graph, let me make this a little bit larger. If I can. There we go. Okay, so right there, it only touches 1 point, only touches 1 point, only touches 1 point, right? Now, big thing, okay, big thing, if I just illustrate points, I'm not connecting them. They're isolated points, so don't connect these points, but only at once do they only touch my vertical line. So then, yes, it is a function. Awesome. Oop. Okay, so we showed you how the vertical line test, and we showed you how to do it by a mapping diagram, by a graph, and by a table. Okay, so what I want you to do is, the next one is not a money problem. I just want you to practice. I want you to draw the mapping diagram, I want you to draw a table, and I want you to represent the domain. Okay, let me write that out. The domain, the range, and whether it's a function or not. And we're using that data right there. All right, good luck.